We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio. AFM Radio.
Hello
AFM
and
Radio.
welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Elena Hyde, and I'm joined tonight by Julie Tomei, who will be part of our famous Julie and Elena show. So every once in a while it ends up being just the two of us. But tonight we are broadcasting live from the nearly fully automated Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. Just as a heads up, this is in fact Science Night in Canada, where the lineup is all Canadian. Starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at about 2 a.m. UT if you're in a different time zone. The York Universe production works in concert with our online public viewing program run by the Observatory team. That's right, you can catch them right now. It also runs between the hours of 9 to 10 p.m. local Toronto time. To follow along, you can go to our new website. That's right, if you missed it last time, we do have a new website link. That's www.yorku.ca/science/observatory. Don't worry, if you use the old one, you'll still get to the site and you'll be able to follow the links to OPV or online public viewing. Join in the chat. It is in fact on our YouTube channel. So if all of that is too confusing, you can always go to YouTube and search for York University Observatory or Allan Carswell Observatory, and the channel will pop up, as will our fabulous OPV chat. They are showing lovely, lovely imaging, and if the clouds clear, we might even try to do some live images. This broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have of our past shows or suggestions for future topics, you can email us at observe@yorku.ca, and if you're on all the social medias, you can connect with us on Twitter with our handle York Observatory, Instagram at York U Observatory, and Facebook at Allan Carswell Obs. Sorry, they're all different, but all of our programs are free. And finally, if you would like to make a donation, you can see that new website, yorku.ca/science/observatory. We'll be monitoring the chat room for questions. And, you know, the current weather, as I say, is fairly cloudy, but we do have a pretty good show planned for you tonight. How are you doing this evening, Julie?
I'm doing okay, thank you. How are you?
Oh, watching the clouds go by, it doesn't look particularly promising for opening tonight. Is it cloudy up where you are?
Yeah, there was even some freezing drizzle earlier.
This time of year in Toronto is not great for astronomy.
No. It's not great for much of anything.
Well, you know, there have been, I was looking around for This Week in Space and Astronomy History, there have been a conspicuously large number of January events, not so many in Canada for astronomy that I could see, for probably good reason. I think this is probably the worst weather time of year. We tried to open the telescope on Saturday when it was predicted to be perfectly clear on the clear dark sky, which is a wonderful sight, by the way. And it was cloudy. The clouds rolled in at exactly 5:30 and covered the sky. So it has been one cloudy night after another. Fingers and toes crossed, we start getting a little bit of clearing here.
I can't remember the last time I saw even just sunshine for more than 10 minutes.
Oh, that's bad. Yes. Well, we should definitely clear some of that out for you.
I would appreciate it. Not that you have the power to do that, but you know, if you did.
Well, as my great aunt would say, you've got to put the whammy on it. It's, you hope really hard and sort of wiggle your fingers in that direction, and that's all we can do in astronomy when it comes to weather, unless, of course, we get off of the planet, which is becoming easier and easier. So if we were to go into space without any atmosphere, all of our problems would be solved.
Yes.
Of course, the new problems would probably be a little bit of an issue.
Well, we can send things out of the atmosphere. I don't suggest we send ourselves unprotected out of the atmosphere.
Yes, at last count, that was both too cold and very, very low atmospheric pressure. Not for humans, the outer space. But we might get to talk a little bit about some of the interesting humans who have gone to outer space later. So why don't we wander over to a little bit of This Week in Space and Astronomy history. And for our listeners, this is the first broadcast of 2023. So this is actually our first time to blast you back into the past this year. So take it away, Julie.
Happy New Year! Yes. So we are actually going above and outside the atmosphere, I guess, in our first item for This Week in Space and Astronomy history. And we are going a little bit back in time to January 12th, 2003. And on that date, 2 satellites were launched. There was IceSat and CHIPS, which sounds a little bit like a snack. So IceSat stands for Ice, Clouds, and Land Elevation Satellite. It's a very loose, when they start making acronyms, but they don't include all the words, and
So more representative than purely an acronym.
Yeah.
And that an acronym adjacent?
Yes, it's acronym adjacent. It was a NASA mission for measuring ice sheet mass balance, cloud and aerosol heights, land topography, and vegetation characteristics, so an Earth studying satellite. It was in operation in a near circular polar orbit for 7 years and was retired in February of 2010 after the last of the 3 lasers on board failed. And it was decommissioned and re-entered the atmosphere in August that year. It used laser altimetry and had a 91-day repeating ground track. So it would do an orbit in 91 days. It generated loads of data sets, which are still available online. Things like aerosol scattering and backscattering, glacier and ice sheet elevation and topography, reflectance, roughness of the ice and of seas, cloud height, sea ice elevation, sea surface height. It's the ice and glacier stuff, historically, like having historical data for that. Super interesting these days, looking at climate and climate change. So that was the first satellite. The second satellite was CHIPS, and CHIPS stands for Cosmic Hot Interstellar Plasma Spectrometer. So that is a proper acronym. Still a silly one. Also a NASA mission, and this one performed spectroscopy in the extreme UV range. The primary objective was to study the million-degree gas in the local interstellar medium. It was designed to capture the first spectra of the faint extreme ultraviolet glow that was expected to be emitted by the hot interstellar gas within the 300 light years of the sun, an area that was often called the local bubble. The measurements, however, produced a null result, with only very faint extreme UV emissions detected, despite theoretical expectations being for much stronger emissions. So I've got a couple of quotes here from the NASA CHIPS website. So the first one is, quote, "Scientists had believed that much of space between nearby stars was filled with hot plasma at a temperature near 1 million degrees Kelvin. Either the interstellar medium is not at the temperature expected, or is significantly depleted in iron, or is located behind too much absorbing gas. CHIP's observations of the full moon or of diffuse emissions from the Earth's outer atmosphere confirm that the instrument operated properly on orbit. So it was working properly, they just didn't observe what they were expecting to observe. So after they didn't observe what they were expecting to observe, they converted CHIPS to a solar observatory in September of 2005 and performed observations of the sun from April 2006 through to April 2008. So about the solar observations, the website had to say, the CHIPS spectra clearly show that the standard plasma model used to synthesize the solar spectrum does not match features in the actual spectrum. In particular, the standard plasma model overpredicts emissions from plasma at temperatures below 1 million degrees and above 2 million degrees Kelvin. This disagreement is important in cross-calibrating and interpreting the results of timed source, SOHO, DDS, GIS, and Solar Dynamics Observatory, as well as modeling the photochemistry induced by solar radiation in Earth's and planetary atmospheres. And operations ended after that stretch of observations in April 2008. So this feels like the satellite that was like, I know what you think is happening, but it's not what's happening.
Well, and it is, I suppose, a little argument for, making sure that you are correctly calibrated with whatever measurements you are trying to make, because being off by, what was that, million degrees, that seems like a lot.
Well, yeah. And so, like, it sounds like it was operating as it was supposed to be. So bit of a mystery there. I don't know if other missions were sent to follow up on these observations, or if it's kind of back to the drawing board on the theoretical, but interesting. And a mission that I hadn't heard of before I was doing my research for today.
Yeah, it's really nice to see some Earth observations pointing the other way. In astronomy, we do sometimes get asked, of course, about, how does astronomy sort of influence or go along with Earth-based sciences. So if you are interested in global warming, which we all should be, or weather chaos, as we've been starting to call it, but these kinds of missions are good for not only increasing our space science capability, but also monitoring, as you say, glacier and ice sheet elevation and all that good stuff. So this is a wonderful overlap area between ourselves and actual Earth sciences, who could probably tell us what went wrong here.
Oh, absolutely. And I mean, we had two different missions here, right? There were two different satellites.
Yes.
And from my understanding, like Earth observation, that's something that like the CSA and the Canadian space community does quite well. And so, yeah, it's not all about, I used to say when I was still working at the observatory, when we were doing our tour of the solar system, we'd get to Earth and be like, well, Earth is great. It's where we live. It's fantastic, but that's what everybody else studies. Let's move on. But it's pretty important. We don't have anywhere else to go. And there's so much we don't understand about it. And there's so much that the technology that we use to look out can tell us looking back in.
Oh, absolutely. And some of the most sort of poignant arguments I've seen for taking care of our planet to make sure it stays livable for us come from pictures from the moon looking back at Earth. And it's like, oh, yeah, this is it's just this thin little layer of atmosphere. And this is really the only planet that has the air we can breathe and water we can drink and plants that we can eat. So
Yes.
would behoove us to keep a perspective. So that's always nice to find overlap areas like that.
Mm-hmm.
Well, I have a not entirely, not entirely space-oriented blast from the past myself. It's rather than launching into space, I'm going to go back in time a little bit further, all the way back to 1771, when they were thinking that, well, actually, all of the planets of the solar system might be inhabited, and there were actual drives for, people trying to make sure that, if we did the communities that we would definitely find on all these other planets, on the moon and on the sun, and everything would be well looked after. But 1771, we couldn't get into space yet. We did not have the rocketary technology, or rocketary might not actually be a word, but we were missing the rocket. It is now. And we were looking up, trying to make sense of it. And one person was actually doing a wonderful catalog that we still use. So Charles Messier, around this time, in 1771, was busy making the famous Messier catalog. And if you haven't heard of this catalog before, this is a wonderful, wonderful set of objects that he discovered as a way to avoid things that were not comets, I believe.
Yeah.
And it was a wonderful set of galaxies and nebula and clusters. He discovered not only a lot of galaxies, but the list itself is part of a bit of a contest that you can try to observe. It's 110 astronomical objects, and I believe this year it's sometime in March or April, something like that. That we get a chance to observe all 110 of them. So if you're fast enough, you can actually catch them all. The Pokemon of astronomy, if you will.
And the challenge is to get them all in one night.
Yes, in one night. If it takes you more than one, that's okay with me. But the challenge is, can you get all of them in one? And of course, there's star clusters and nebula and galaxies. And the fun thing for astrophotographers is that these have variety of different types of objects that you can collect. But Messier was doing a lot of things in the 1700s. There are many timelines for him. The most astronomical objects seem to have picked up around 1758, when he's making his first sort of comet observations. And he actually started out looking for Comet Halley, and found M32, what is now called M32. And he's like, this is not Comet Halley, how annoying, and wrote it down. So he made that comet observation, and he kept his table of not comets so that he wouldn't get tricked again by them. And of course, he discovers M1, which is the Crab Nebula, and goes on and on and on, all the way up until 101, I believe. Make sure I say the right number here. 110, 110, 110, not 101. Watch out, people. So the final version of his catalog had 103 objects, but they actually used his side notes and filled up the list to be 110. So this set of objects being around this time of year is a little bit surprising, because our weather is terrible, but he was not in Canada, so that probably helped. So he discovered, along with his comets, a whole bunch of these fun Messier objects. But I wanted to call attention to a particular comet that you might not have heard of. So he actually found on January 10th, that is tomorrow, January 10th in 1770, January 10th, Lexell's comet, which is not named after him, but it was observed by him in June 1770 and then written into his comet catalog on January 9th. So he discovered the comet as along with a popular orbit computer, Anders John Lexell. I'm not sure if I'm saying the last name right. He is Finnish-Swedish. So if you have some notes about pronunciation, let me know. This was called one of the great comets. Lexell's comet 1770 passing actually still holds, I believe, the record of closest observed approach of Earth by a comet. So that's, using the orbit calculations. We might have actually had it be beaten by a recent sun-grazing comet. So there's a little bit of debate about which one might have gotten even closer. So the uncertainties in this are around about 1.5 million kilometers. So we are talking about being off by an order of a million before. In this case, it's actually a little bit more understandable because we just don't know the orbits that well. So the constellation was discovered the comet was discovered in the constellation Sagittarius, and he was examining several nebulae maybe to put on his list of not comets, and he found this one, and it was very, very faint when he first saw it, but he saw that over the next few days, coming back to this same object, it was growing in size rapidly. So it was had a coma of about 27 arc minutes across by June 24th, and it was a magnitude +2. That is very bright and very big. This would have been spectacular. It was by this time being observed by anyone or everyone who could see it, and it was actually recorded in Japan as well. So it was a real phenomenon, nice and bright. And it had its, I believe, closest approach on July 1st in 1770, coming within 0.015 astronomical units from Earth. So that's about 6 times the radius of the moon's orbit. So it wasn't flying, in between the moon and Earth or anything, but it was pretty close. And it was about 4 times the apparent angular size of the moon. So this would have been spectacular in the sky. The nucleus would be perhaps around the size of Jupiter, it's thought. So Messier was also the last to observe this comet as it moved away from the sun on October 3rd, 1770. So at the time, they actually thought that all comets originated outside the solar system. And the orbits that they used parabolic models, which is really interesting. But Anders Johann Lexell suggested that this comet followed an elliptical orbit and actually traced it out. And it was identified as a sort of a Jupiter family comet, and it was a very, very near Earth object. So got a lot of fame at the time. Comet Lexell was never seen again, but it has remained interesting to astronomers ever since. So there was a prize offered by the Paris Academy of Sciences for an investigation into the orbit of this comet, and the winner didn't happen until 1801. Johann Karl Burckhardt actually confirmed the calculations of Lexell. So his calculations being the first real correct model is why he actually gets the comet named after him, which is pretty cool. So this 1779 close approach drastically altered its orbit. We think that it has been left with sort of a short perihelion, and probably there's still some work to be done there. There was a recent paper I was looking for. Have they updated the math at all? And in 2018, there were some recalculations of this particular comet's orbit, and they simulated the orbit forward to the year 2000, finding basically that 98% of possible orbits would remain orbiting the sun. So maybe we might still be able to find it. I suppose some new prize might need to be offered or something. So Lexell's comet, discovered by Messier, is one of those sort of hidden gems, I think, that you get in astronomy sometimes. And cometary discoveries all in, I would just like to mention, Messier has a huge list, which I cannot even begin to start reading out here, but a lot of them were also co-discoveries because bright comets are very spectacular, and around this time the technology was improving. So if you're interested in more, you'll have to catch like the biography book or something because there are many cometary discoveries. This one, however, was documented on 9 January all the way back in 1770. So Comet 1772, or Lexell's Comet, also called the Great Comet.
Nice. I love old-timey drawings of comets.
Yes.
I've said it before, and I'll say it again.
And there should be some real gems from this one out there just because it was so bright. I haven't been able to find any great pictures myself, but there should be some out there.
I found a lovely one on earthsky.org.
Okay.
It's black and white, obviously. It looks like a bunch of people, very well-dressed people, all looking up at a sky, which is just like comet from one side of the sky to the other.
Yeah, that does fit the description that we have from Messier's notes. And of course, the nucleus being the size of Jupiter, that would have just been the sort of the brightest part. The surrounding region was larger, substantially larger than the full moon. Yeah. So you would get quite the show. I think we cannot promise anything like that for this year, but you never know. We might get lucky.
It's pretty fantastic.
All right, so zipping around through space and time, I've taken us back for a little bit of a distraction, I suppose. But it does just mention that if you want to have fun and look up, sometimes you don't need to get out of the atmosphere if your object is bright enough and you've got clear skies. That said, I think you do have another way to get us out of Earth's atmosphere for your next item.
Yeah, I was on a bit of a satellite kick this week, I guess. So we're going to January 15th, 2008 with the launch of Thuraya 3. And partially what interested me was the name. I was like, that sounds pretty. Also that it's a satellite launched by a country we don't often talk about when we talk about space launches. This is a commercial satellite. So this is United Arab Emirates geostationary communications satellite. And it was launched from a floating Pacific Ocean platform. Thuraya is the Arabic name for the Pleiades. And I'm always liking to learn other names for the Pleiades because it comes up in like everywhere. And so Thuraya Telecommunications Company operates 2 satellites currently and provides voice and data coverage for 161 countries in Europe, the Middle East, North, Central, and Eastern Africa, Asia, and Australia. And so the first Thuraya satellite was launched in 2000, but it had some deficiencies in its solar panels and didn't operate properly, but it was used for testing and backup until 2007. They launched a second satellite in 2003, and then the third one January 15th, 2008. And there are plans for a fourth satellite launch. This one next year in 2024. This one would be via SpaceX. The first 3 satellites were launched by Sea Launch, which was a company that operated from 1995 to 2014. And they launched commercial payloads from a former mobile floating oil drilling rig that they renamed Odyssey, which is kind of cool. But I think politics got in the way because the company was a multinational between Norway, Russia, Ukraine, and the US. And they went on long-term hiatus following the Russian military intervention in Ukraine in 2014. And the company's assets were purchased by the S7 Group in 2016, with plans to start sea launches again, but they seem to be up in the air because I went to the company's website and it's like, yes, we will start launching in 2018. And there's like nothing. Anyways, thought it was kind of interesting. I like geostationary satellites. They're cool. And it had a pretty name.
Oh, yeah. And it is always interesting to hear what other folks are up to as well. There have been a staggering number of launches recently, but we are seeing more and more from the UAE, actually. And I remember the first time they really jumped to the forefront of astronomy news was, of course, with the HOPE probe for Mars. At least that was the first really big one that I'm aware of. That sort of made the UAE the first Arab country and the 5th country overall to actually reach Mars. And it was only the 2nd country to actually manage to successfully enter Mars's orbit on the first try. So they did successfully enter orbit, and there's a lovely picture of Mars that came back from that probe. I'm actually not sure what the latest is on the HOPE probe, but it just goes to show we are seeing more and more different countries getting into space and creating their own satellites, creating their own missions, and now, of course, another one for a geostationary communication satellite, which will be joining the many, many, many communication satellites which are already up there. So hopefully it doesn't have too much of a problem with the space junk, the sort of issue that's getting to be more and more of a thing to watch out for.
Yeah. I mean, if you think about it, it makes total sense that the UAE would have the engineering prowess, if you will, to put, to do Mars, to put stuff in space. Like, this is the country that is a desert country and you can go skiing because they built a place that you can do that.
Yeah, and there are a lot of very advanced engineering structures.
Right.
They
build
UAE.
Giant buildings. They build islands to put those giant buildings on.
Very intricate giant buildings as well.
Yeah.
Anyways, all buildings aside.
Yeah, lots of engineering happening in the UAE.
It is always interesting to follow along with. Perhaps, let's see, we are about at the halfway point, so I might just take a little break and remind everybody that you are, in fact, listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Our website, as mentioned before, has in fact changed just a little bit. The old one will still get you there, but if you want to find us directly, you'll need to type in yorku.ca/science/observatory. Once you're on there, you'll be able to find the OPV, which you can click on to join in with chat for our crew, online public viewing. They're showing some lovely images over on our YouTube channel. So if you want to join in on Twitter or Facebook, or of course live on YouTube, feel free to hop in. Tonight you are listening to Julie and Elena. We are discussing all things going up, I suppose. Buildings and comets and all kinds of different things. Our new website, as a reminder, is yorku.ca/science/observatory. Click on online viewing on the menu bar for OPV to join in now. So that said, for our little reminder of where you all are, there is also an extra reminder that this being the first week back after the Christmas break, we will be having a regular Teletube episode over on Wednesday night at 7:30 p.m. on YouTube. So if you'd like to join in with that, it's again from the same website, but you can hop in and join in for our first of 2023, just like this one, but a little bit more polished, I suppose. So we're looking forward to lots and lots of events this year, and I suppose first, before we get too far along talking about what we could do, let me go ahead and do my last This Week in Space and Astronomy history. So I did have another one that's again sort of out there, but goes a little bit more with the idea of escaping Earth's atmosphere. So all the way back in 1839, we were seeing the first kind of calculations from people who were looking to find distances to other stars. And Alpha Centauri is, well, one of the most interesting. It has always been one of my favorite objects in the southern hemisphere. It's easy to see in the night sky. In the northern hemisphere, you need to travel to the southern hemisphere to see it. But it's unusual for a bright star. Alpha Centauri doesn't have a sort of commonly agreed proper name. It's called different things by different people. So Arab astronomers call it Rigel Kentaurus, which is the foot of the centaur. Some people call it Rigel Kent. The Chinese refer to it as Nanmun, or the Southern Gate. And of course it has names in all kinds of different languages, but there's no universal agreement. There's no IAU definition. Alpha Centauri is generally just called Alpha Centauri, but it is the closest star system to us. And no, I didn't say star, I said star system. So Alpha Centauri is actually 3 stars, and we'll talk about that a little bit. But on January 9th in 1839, Thomas Henderson, a Scottish astronomer, finally released his findings about this system, because we didn't know how far stars were away from the Earth. We could tell they were far away because otherwise, of course, it would be easy to measure their parallax. And parallax itself was actually one of the main driving reasons for people disbelieving the sun-centric solar system, because surely we would be able to measure parallax to stars, unless, of course, those stars were just ridiculously, really, really, really far away. Of course, they are ridiculously, really, really, really far away. So measuring the first parallax really showed us just how incredibly far it was to the nearest, or to any star, really. So we had Alpha Centauri, which is the closest to our own solar system, but we didn't actually know how close it was. So stellar parallax is a phenomenal thing to be able to detect. It's incredibly difficult. The angles you have to measure are very, very, very small, and it was a huge subject of debate for hundreds and hundreds of years. So the first parallax measurements were made by Thomas Henderson, Friedrich Georg Wilhelm von Struve, and Friedrich Bessel. So some of those names you might remember from reading earlier astronomy texts. But Henderson was the one who was after Alpha Centauri, and he was using the parallax method. He was able to calculate a distance of about 4 light years. That's a little bit less than the agreed sort of modern value, 4.3, but it's really, really, really close. But Henderson, it's quite funny. He's a Scottish astronomer, and of course you have to go south to observe Alpha Centauri. It's not visible from the northern hemisphere, and he really did not like the region he traveled to. He went to the Royal Observatory at the Cape of Good Hope in South Africa, and he just did not like it. I don't know if he didn't like the weather or something, but after 13 months, he was like, no, I am back to Scotland. So he went back to Scotland and sort of faffed about for a little bit, about 6 years or so, because he wasn't entirely confident in his measurements, but he released his findings, finally, on January 9th, 1839. And in the meantime, Bessel, Friedrich Wilhelm Bessel, in Germany, had measured 61 Cygni and published his result first. So this is why 61 Cygni is often called the first parallax measurement, even though Thomas Henderson did it before Bessel, he didn't publish. And so if you've been sitting on a paper for 6 years, join the club, but maybe get it out because somebody else might beat you to it. Maybe your paper has some amazing findings. So yes, a lesson to all of us astronomers. But Bessel does have credit for the first successful parallax measurement with 61 Cygni, being a few months before Henderson. And it is interesting, if you look at literature, if you've read astronomy history books, 61 Cygni is usually called the first parallax measurement, and this is a bombshell, right? Because just how far away are the other stars? And 61 Cygni had a large proper motion, so it was a good candidate for trying to measure the distance to it. And actually, it was measured with the proper motion all the way back in 1804 by a Italian Catholic priest, Giuseppe Piazzi, who was studying the star for over 10 years and realized it was moving really fast. So Piazzi's measurements didn't really get a lot of attention until Bessel published an article later on in 1812. And this sort of flying star or zooming star was, going fast enough that they could measure it even at the time. So parallax, which if you haven't heard of, it uses the Earth's orbit as a baseline. And there's a fun experiment you can do with parallax, actually, if you have a pen and you hold it out at arm's length and look at the background wall, and then if you can cover one eye and then the other, you'll see your pen appears to jump positions. And it's because your eyes, our perception of distance from our own eyeballs actually uses the separation of our two eyes to do a little mini parallax and give us the ability to sense depth, or our idea of depth. So your brain is actually doing a little tiny distance calculation. Not that you'll get the numbers out of it without a calculator, but it is pretty cool. So parallax is that little tiny shift you see in a nearby object when you're looking at a background. If you have some distance between the 2 points you're measuring, it's just geometry, and it's pretty easy. Like I say, you can do this experiment if you've got a pen and a wall. But 61 Cygni has a is not so bright. It's not as bright as Alpha Centauri, and they did have a little bit of trouble with that first parallax. So they got a parallax of 0.3136 arc seconds, or 10.4 light years from Earth. So this at the time would have been absolutely shocking, because 10.4 light years is so incredibly much farther than anything else we could think of. It absolutely throws our whole scale of the universe for a whack. And they did fairly well with the 61 Cygni. Modern measurements say it's 11.36 light years distance. So really, really far away if you compare it to the size of anything in the solar system. But Alpha Centauri, not to be outdone here, this is 4 light years, and having a 4.3 really, but having this early measured parallax of 4, it kind of gave people hope that maybe some things might be a little bit closer. And the 3 stars of the Alpha Centauri system are labeled A, B, and C, but they have some different names. As I say, the Alpha Centauri means the whole system altogether. Alpha Centauri C is better known as Proxima Centauri because it orbits out away from the other 2. So Alpha Centauri A and B are 2 stars that are both like our sun, orbiting each other, and Alpha Centauri C, or Proxima Centauri, is a third smaller star, smaller as in less massive star, that's actually substantially farther away from the other 2. There's some argument to be made about whether or not it's fully bound to the system, but it's Proxima Centauri that is the closest. So we have this really, really interesting system, and we've been looking at it carefully because this is the closest solar system to our own sun. It's really fascinating stuff. And we've been watching it for ages, tracing the orbits. And of course, they have now found planets around Proxima Centauri. So I cannot wait till they start pointing like the JWST at those planets or something, because it's just so cool to be able to see a star that is the closest to our own system already having planets. And if you are wondering what a next January connection might be, interesting little bit of trivia, when we watch the 2 stars go around each other, A and B, their closest approach is about 11 AU to each other. So that's 2 stars like our sun that would have the closest approach of about 11 AU or so. And when they have a maximum separation, they're easier to untangle. And the next maximum separation for the AB stars of the system is in January of 2056. So you heard it here first.
Stay tuned.
Yeah, stay tuned. Stay tuned on this same channel. And in 2056, we will cover it if we're still here. We haven't all moved to Mars by then. So very, very fun stuff. 1839, the Henderson distance to Alpha Centauri is published about 6 years late, and he gets beaten to the punch by 2 months. So maybe don't wait the full 6 years for your next publication. All right, so that is all of our This Week in Space and Astronomy history. We have gone backwards, we've gone forwards, and we've gone out into outer space. So what we'll do for the next section is actually just talk a little bit about some of our top astronomy from 2022, because there's so much astronomy news going on and so many things have happened this last year. I thought, what better way to do a little bit of a round off of the year than to talk about some of our favorite events. And I think we're starting off with a wonderful set here, actually. Shall you mention the lunar eclipses, or shall I?
Well, you already have. And there were a pair, May 15th, 16th, and November 8th. I was conscious for the one in May, and I was not for the one in November. I was so sick in November, I did not set an alarm. I was just like, yeah, no, bed.
Oh, well, I'm glad you seem to have recovered.
Yeah. It's just a massive cold or something. But I do remember going, eclipse. Yeah, no.
We were able to
get one.
So, yeah, it is. If you saw the November one, that's probably good, because there's not going to be any this year. So 2022 was a great year for the moon, a fabulous year for the moon. We had 2 beautiful lunar eclipses visible from Toronto, and this year none. So
there are going to be lunar eclipses, just not visible
for us.
Not for us. You're going to have to go to like Europe, Africa, the other side of the world.
if you really want to catch fun, you'll have to plan your
Gonna have to
vacations
travel.
accordingly.
Mhm.
But yeah, it was quite fun to have, I think, 2 in 1 year. It was a little bit interesting because we went out with the observatory crew and captured a bunch of images. I think for both on the atrium and at the observatory, and I can't remember now which one we ended up streaming from Killarney Park. I think it must have been the earlier one. Because we did have our astronomer in residence program running at the same time, which I think is a different item on this list.
It is, but we can meld them together.
We can meld them together. So we actually did. Yes, it was May. It was May lunar eclipse, May 15th and 16th. We had our first astronomer in residence live stream on YouTube with live footage from the Killarney Provincial Park, which is a dark sky site, and they had almost perfectly clear skies, and we had almost perfectly cloudy skies, and we were trying to catch some of the lunar eclipse in between the clouds up on top of the parking garage with all of the tiny telescopes, but we couldn't quite get it, so we had the projector screen set up, and we projected the live image from Killarney onto that screen and onto YouTube. So you can still see that footage. I suppose if you go to the live stream playlist.
Nice.
So May 15th to 16th lunar eclipse was a fun one. First eclipse live stream from Killarney Provincial Park with the Allan Carswell Observatory. And the entire eclipse was visible from start to end for this one. So in Toronto, we were close enough to the Killarney Provincial Park. It's basically the same time for us. And the this eclipse was also viewable to all of South America as well as Antarctica, but you would have missed out if you were in Europe or in Africa. So I suppose that we're sharing the lunar eclipses is what we're doing.
Well, that is how it works.
It is how it works. Well, and exactly. And if you actually go and look at those nodes that line up for lunar and solar eclipses, it all does mathematically work out very well. So excellent. So eclipses and astronomer in residence. And of course, I would be remiss without saying this inaugural air season did feature, of course, yourself, Julie.
And yourself.
And myself. And I believe about 10 other people as well.
Oh, yeah, absolutely. Loved it. Planning on doing it again.
Oh, you should.
Yeah, as soon as the website gets updated.
Oh, yes. Well, you'll have to all give me a few more days for that.
It's all good. It's all good.
We did have that entire website change URLs, so there's a few things that haven't been completely fixed up at the moment. Yeah, but as soon as it is open, everyone is welcome to apply. If you're planning on going as a visitor, I will say you don't have to apply or do anything. You just go up to the park when there is an astronomer in residence, and the park visitor center lists what tours are running on what week. Usually there's one or two evening events and a sun event during the day. Solar observing is also fun.
Yes, we had a lot of fun solar observing when I was there. Had some nice sunspots.
Yeah, the sun getting more active is definitely making it a lot of fun to watch. A little bit nerve-wracking sometimes, but very, very nice nonetheless. So we have our inaugural air season as one of the best of 2022, no doubt. And I will just say as a personal favorite, for 2022, there was a particular observatory that happened to get 2 new domes. Of course,
did I miss that on the list when I made it?
Well, the domes are near and dear to my heart and my planning. The new domes of the Allan Carswell Observatory. If you haven't heard, the old domes were the original domes from 1964 when the building was built, and they were very, very old. They had holes and other problems. And of course,
problems.
Yes. And fortunately, after some amount of planning and a great deal of convincing, we were able to get approved for a new dome project. And we have now 2 new ash domes, which are actually exactly the same size as our old ash domes, but they have a drop out shutter instead of a pull up shutter, which is actually hydraulic and really cool. And they're programmable, which means that we can now sync the domes to the telescope movement. And if you've ever been out in the dome pushing the button to make it go along with the telescope, you can understand why automating it might be really, really good. Especially when it's super, super, super cold. We can now do programming routines, and we have an entire network rack which has been put in with a brain of 5 computers, and it is all entirely programmable. So we are now looking at the future of space in our very own Allan Carswell Observatory with these new domes. So top 20 of 2022 for me, for sure.
You're turning me into like one of those people that walks in and goes, back in my day, nothing was automated. We fought with this thing that didn't work, and we were here all night.
There are still things you can fight with, but now they're code.
All joking aside, it's amazing. The domes look fantastic. I loved seeing the pictures of the observatory with its shiny new domes.
Oh, yes. And when you go in and you log in and look at the cameras on the inside and there's no leaks whatsoever,
That's fantastic.
The best feeling of all time. So looking forward to showing off our new automated control processor at some point once we finished hooking up those last pesky software links. But definitely has to make the list. So I think we also have a couple fun objects of planets. Mercury, Venus, Mars, Jupiter, and Saturn from mid to late June were all visible in the wee hours of the morning. So there was actually a pretty awesome planetary alignment in the very best of this planetary alignment. Mercury, Venus, Mars, Jupiter, and Saturn was actually up on the morning at 5 a.m. when we all went outside to get the crane to lift off the domes for the observatory. So how cool is that? We actually had a planetary alignment during our redoming.
Well, that is just beautiful.
Now we have a couple other items, so I'm going to let you pick one, Julie.
Sure. I don't know. What do I want to pick? Let's go with JWST and all the pretty pictures.
That's gotta be one of. I mean, there's no question, right? So James Webb Space Telescope in 2022, it had its first flight. It amazed everybody. I mean, the images coming out of this telescope are jaw-dropping. It really is doing everything we asked it to and more.
Absolutely. Every time there's new images, it's just like, didn't think I could be more impressed with space pictures. Thought I'd seen it all. No, there's even more pretty.
Yeah, it's been absolutely astonishing. And of course, it launched on Christmas Day of 2021 and came online only in late June of 2022. And immediately we just started getting our socks knocked off. The Pillars of Creation with the Eagle Nebula was immediately thrown up next to the Hubble telescope image. And of course, exoplanets. We're just talking about the planets potentially around the Alpha Centauri system and the planets definitely around Proxima Centauri. Well, Webb actually did a direct image of an exoplanet substantially farther away, too.
And it's images of, like, planets in our own solar system.
Yes. And of course, the moon, Titan, the Saturn's moon Titan, very intriguing place. They had an image of a cloud which seemed to be shifting around a little bit. So cloud images, ring nebula images, a brown dwarf with some sort of potential sand clouds, and atmospheric compositions coming in. We could probably spend another hour just talking about this one, but I don't think we're going to be able to. We're going to have to say
definitely don't have time for that, unfortunately.
No, we don't. There are so many amazing things that happened in 2022. We weren't even able to get to all of them. So I will leave it to our listeners to come up with their favorites. And I will go ahead and say thank you, everyone. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Elena and Julie. And stay tuned because it is Astronomy Night in Canada. Thanks for tuning in to York Universe, clear skies, and have a good night.
Good night.